So for this lab, what we're going to be doing is we're going to be determining the identity of a group 1 carbonate. We know it's group 1, but we don't know, is it lithium carbonate, sodium carbonate, or potassium carbonate? So what we're going to do is we're going to react our group 1 carbonate with a solution of calcium chloride. That will cause a precipitate to form. We'll generate calcium carbonate. We'll collect that calcium carbonate via filtration and use the mass of that precipitate to ultimately figure out what the molar mass is of this unknown carbonate. And once we know the molar mass, we can identify which of the group 1 metals this carbonate is. But before I can actually start this reaction, what I first need to do is I need to take my crucible, which is what I'm going to be using to heat, and I actually need to drive off any water that might be on the crucible. The thing with this lab is that we need to be very precise with our masses, and even a little bit of water that would increase our mass could mess up our results. And so the way that we drive off the water is we simply heat it up. So the setup that I have here, I have my ring stand, my Bunsen burner, I have an iron ring and a clay triangle. Now the point of the clay triangle is just to make sure that the crucible doesn't fall through. Notice that I'm heating my crucible without the lid because we want the water to evaporate and escape. I don't want to trap the water inside. And then in addition, the balance that I'm going to be using when I need to weigh the crucible is an analytical balance. So our analytical balances, you can see they have a lid here because they're very sensitive. Even airflow in the room can cause the mass to fluctuate. An analytical balance will record the mass to 3 decimal points. So I'll be able to record the mass to the nearest milligram. Again, I need that precise data. So that's why I'm using our analytical balances. But first, like I said, I need to heat up this crucible to make sure there's no water present on the crucible. So what I want to do is I first actually want to light the Bunsen burner off of the ring stand. And the reason I'm doing this is that if I need to adjust the height of the iron ring or the height of the flame, I don't want to have this here. I turn it on and now this is getting hot and now I can't touch it. I can't raise it or lower it. So I just move it off of the ring stand. I turn on the gas. And light the Bunsen burner, and then I can kind of just eyeball from here. All right, let me lower the gas a bit so the height of the flame, and then I also want to raise this up just a little bit as well. This part of the Bunsen burner doesn't get hot, so even though it's on, I can touch this. And then you want to let this sit for about a minute, 30 seconds, just to drive off, again, any water that might be present, so that when I weigh this crucible, I have a clean, dry mass. So I'm gonna let this heat up, and then you can even kind of move the Bunsen burner around a little bit and make sure you kind of get all the sides. Okay. So once I've driven off the water, simply turn the gas off. Now, I don't want to touch the crucible. It's gonna be hot, so I'm gonna use my crucible tongs. And I'm gonna let this cool on the base of the ring stand. You never wanna put it on the bench top because you could burn the bench top. So the base of the ring stand is where you wanna let it cool. Now notice I did put the lid on. So why am I doing that? Now that I've heated it and I've driven off the water, I don't want any water that's in the atmosphere to condense back on. So I'm putting the lid on while it cools so that no water can get into the crucible. So I'm gonna let this cool, and then I'm gonna weigh it. And once I've done that and recorded that mass, I'm going to add my 2 grams of my unknown carbonate, and I'm gonna heat that again as well. Okay, so now that my crucible has cooled down, I've recorded the mass of the empty, dry crucible. I then added the sodium carbonate to it, and you can see that's at the bottom of the crucible here. Now, I need to heat this as well. The group 1 carbonates are hygroscopic. They do absorb water from the atmosphere. And so even though I've already weighed out approximately 2 grams, and again, I've recorded the precise mass in my lab notebook, that mass has water in it. And I need the mass of just the group 1 carbonate. So the way that I'm going to do that and determine what that mass is now I'm going to heat this. But here's the thing, I can't just heat it once because I need to know that all of the water is gone. And the only way I'm gonna know that all of the water is gone is if I heat it more than once and weigh it each time. And what I'm looking for is when the mass stops changing. Because when the mass stops changing, I know that I've evaporated all of the water and the only thing left is the ionic compound. Ionic compounds have very high melting points and boiling points. So heating with a Bunsen burner is not going to cause the ionic compound to evaporate. It's only causing the water to evaporate. So I'm going to use my Bunsen burner again. I'm going to heat this. I'm going to let it cool, and then I'm going to weigh it. And then I'm going to heat it again, let it cool, and then I'm going to weigh it. If those two masses are the same, I know that I've driven off all of the water. But if the second mass has gone down, well, now I know I need to heat it a third time. And so that's just something to be aware of. Every time you do this lab, you need to keep heating and then weighing until you get to a consistent or constant mass. All right, so that's what I'm going to be doing now. All right, so now that I have my unknown carbonate heated and dried to a consistent mass, now I actually need to add water to it. So I'm gonna add water to this for when I react it with the calcium chloride. I need to measure out about 200 milliliters of water. Now, yes, beakers do have volume markings, but a beaker is not a precise enough way of measuring volume. We really never use beakers to measure volume. We always want to use a graduated cylinder or pipette or burette, something like that. Never a beaker or an Erlenmeyer flask when we're measuring out a volume. So I'm going to add approximately 200 milliliters. The exact amount of water is not important, just enough that it will dissolve. And then I'm going to take my stir rod and just make sure that all of that group 1 carbonate has dissolved. Let's sit there for a minute. And then while that's, kind of still stirring a little bit, I'm also going to measure out the calcium chloride solution. Again, I don't need a precise volume. That's why I'm not using a burette or a pipette. A graduated cylinder is perfectly fine here because the calcium chloride is going to be added in excess. The unknown carbonate, that's our limiting reagent. That's why we really needed that very precise mass. But the calcium chloride solution, I'm adding in excess because I want to drive this reaction to completion. So I'm going to measure out 125 milliliters. Give this one again, just make sure all of that group 1 has dissolved. That looks pretty good. And so once I add this calcium chloride, we're going to see a milky white precipitate form. And that's our product. That's the calcium carbonate that is not soluble in water. Calcium carbonate is chalk. So if you've ever tried to dissolve chalk in water, it doesn't work. It's not soluble. So as soon as I add even a little bit, you can see that milky white solid form. Now, obviously the reaction started. I still want to stir though, to make sure that I get a complete reaction. So I'm going to be stirring this for about 5 minutes. And then I'm going to let the precipitate settle down to the bottom. As we'll talk about, that's going to make our filtration a little bit easier. Okay, so now that my reaction is complete, I need to collect my precipitate. I'm going to collect it on this piece of filter paper here. And what I'm going to do to collect my precipitate is what's called a vacuum filtration. So in a vacuum filtration, what we use is a Buchner funnel, which is this here, has a rubber stopper, which creates a nice seal. And then this piece of glassware is what we call a filter flask. It's also sometimes called a sidearm flask because of this piece right there. This hose is connected to an aspirator on my benchtop sink. And so the point of this is that when I turn on the water here, the force of the water coming out of the sink is actually going to draw a vacuum. And that vacuum is going to take any solution that's up top here and suck it down into the filter flask. So the advantage of doing a vacuum filtration over a gravity filtration is simply speed. A vacuum filtration is going to allow me to filter 400 milliliters of solution much more quickly than a gravity filtration would allow. So I have already weighed out my piece of filter paper using my analytical balance, and I've recorded that mass in my lab notebook. I am going to add a little bit of DI water here. And the point of the DI water is just to help the piece of filter paper stick to the bottom of the Buchner funnel, because I don't want any of my product to get underneath the filter paper. I need all my product on that filter paper. Now, when I turn this sink on, you're going to see that water that I just poured is going to get sucked down into the filter flask. So now what I'm going to do is pour my reaction solution into the funnel. Now, I don't want to pour too quickly because I don't want to overfill the Buchner funnel. I also want to be careful because this sidearm flask only holds 250 milliliters, and I have 400 milliliters of solution. So I'm just kind of keeping an eye on the liquid level here. So what I'm going to do is I'm going to completely filter all of this, making sure that any solid at the bottom, that's my product, that's the calcium carbonate. I need to transfer all of this solid onto this piece of filter paper. Okay, so that's what I'm going to do now. Now that I've filtered all of my solution, I have my piece of filter paper with our calcium carbonate precipitate. I put it here on this watch glass. Now, I need a mass of our calcium carbonate, but this is wet. It was in an aqueous solution. So just like before we started the reaction and I heated the unknown carbonate to drive off any water, I'm going to do the same thing with my product. What I'm going to do is I'm going to take the filter paper with our product on the watch glass. I'm going to put it in a drying oven, and then I'm going to take it out, let it cool, and weigh it. And then I'm going to put it back in the drying oven, take it out, let it cool, and weigh it. And so just like with before, the only way for me to know that all of the water has evaporated is for me to heat it until I get a consistent mass. And so I can't visually assess if all of the water is gone. And so I might have to heat it twice, I might have to heat it a third time, but I'm going to keep putting it in that drying oven, taking it out, letting it cool, and weighing it until I get a consistent mass. Once I have that, I can take that mass, and then again, ultimately what I'm trying to figure out here is the molar mass of my starting material, of the group 1 carbonate. Once I know that molar mass, I can identify which group 1 metal the carbonate was.